this was your sort of a check for understanding, even though we didn't practice too much on this. But you could look at your notes, right, and try to use them to do this. I'm going to, I guess, do a little review of the things that we had mentioned in class. So, law of exponents. The simplest of them is we've been working on this. So this you already knew. Let me add a 3, and then let me rewrite that. So let's say 3 a to the third, b to the second times 7, 8, b. Well, right there, we know that this is all multiplying. And if I were to write this in extended form, right, we can actually sort of rearrange the problem. We can write all the coefficients together, 3 times 7. And then let me expand on the a third and write a times a times a. And let me bring this guy over here. Right, a. b to the second power is 2b's, right, being multiplied, and then this last b. So that's what it looks like expanded. Nobody wants to do this, right? We can just... But this shows you that, what are we doing? We're multiplying the coefficients. 3 and 7 is 21. A times a times a times a is just a to the fourth. And b times b times c is b to the third. So we know that the shortcut would be to keep the, if we were multiplying, right, and the bases are the same, we can just simply add the exponent. So going back to the original problem, well, we can 3 times 7, well, we can multiply these two, so we get 21. Then a third times a, right? Well, we know that we keep the base, and there's a little 1 here. We add the exponents, 3a to the fourth, and b to the second, and that little 1 here. B to the third, right? So that's the shortcut. Then you get the same answer. So that was the product rule. Now the quotient rule. We got 4 to the fourth divided by 5 to the second. Well, if the product rule was had the exponent, the quotient rule was probably what do you call the opposite, which would be subtraction. So let's see if that makes sense. So keep the base, subtract the exponents. And we get 5 to the second, or 25. Now, we can rewrite this as this, right? As a fraction. Better yet, let me show you something else. If we expand that, we get 5 times 5 times 5 times 5. And now at the bottom, we have 5 times 5, right? Twice. Now, you know that we can simplify this too. To both be multiplied by 5, we get a 1 and a 1. Simplify this and this by 5, we get a 1 and a 1. So 1 times 1 times 5 times 5. Look at that. We get 25. And at the bottom, we only have 1. 25 over 1 is just 25. Did we get the same answer as this? Yeah, we did. So with division, we keep the base and we subtract the exponent. Now, what that's going to lead us into is negative exponents. So let me reverse this and write it like that. So you're going to say, well, 5 to the second divided by 5 to the fourth. Well, if the quotient rule says keep the base, subtract the exponents. And that's going to get us to negative 2. But you, right, are going to say, well, I don't know how to deal with negatives. So let's use this in the fraction format. And that's where I think this is going to help. 5 to the second over 5 to the fourth, right? And let's expand it out. So on the top, I have 5 times 5. At the bottom now I have 5 times 5 times 5 times 5. If we simplify this, these two become 1, these two become 1. So now I'm ready to simplify the top. I only write 1. I'm left with 1, and at the bottom it's 5 times 5, which is 25. So this and these are the same. So we know now that 5 to the second, negative second power is 1 over 25. The shortcut, and then from this, you know, and the more you did this, you would have, you know, I don't know, let's just do another one, 3 to the 8th and 3 to the 11th. So what would that look like? Well, if you wrote it horizontally, you write 3 to the 8th divided by 3 to the 11th, keep the base, subtract exponents, you're left with 3 to the negative third power. If we do it here as a fraction, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Remember, they're all being multiplying. So I can simplify this 3 with this 3. These 2, 3, 4, 5, 6, 7, 8, right? Top and bottom. So these all become 1, 1, 1, 1, 1 at the bottom, 1, 1, 1, 1. So if we simplify this, I get 1 at the bottom, get 3 to the third power, which I can 3 times 3 times 3 is just 1 over 27. So, and the more you did that, you realize, oh, there's a pattern here, right? Which we can now say that anything to the negative power, so a to the negative m power, in order to change that to a positive exponent, all I gotta do is throw this here at the bottom, right? That's a shortcut, so it becomes a to the m. So if you had 8 to the negative, I'm going to make an easy one, 8 to the negative second power, that becomes 1 over 8 to the second power. My exponent is now positive, and then that becomes 1 over 64. Okay, so that's how that would work. So that's your quotient rule and the explanation of your negative exponent. And then we had something to the 0 power equals 1. How do we explain that? Well, again, let's use this example. 6 to the third power divided by 6 to the third power. Well, quotient rule says keep the base, subtract exponent, and we get 6 to the 0. But I still don't know how that became 1. Well, let's write as a fraction. Write as a fraction, you get 6 times 6 times 6 on top, 6 times 6 times 6 on the bottom. Well, if you simplify this, that becomes 1 and 1. This becomes 1 and 1. This becomes 1 and 1. So 6 to the third divided by 6 to the third is just 1. Isn't that the same thing as this? 6 to the 0. And that's why 6 to the 0 is 1. Okay, so I hope that helps you understand where the 1 comes from. The expanded rule. So let's say you had 5, a to the second, b to the third, to the second power, right? So remember, there's a 1 over here. So in reality, what is that telling you? That's saying take whatever is inside the parentheses, and multiply it by itself twice, right? Then we keep the base. So let's multiply these two. We get 5 to the second. Keep the base, add the exponent. The a's keep the base, add the exponents, and the b's keep the base, add the exponent. Right? Now you could have done that, and depending, and I guess if this was I can imagine if this was a 20, are you going to do 5a squared b cubed times 5a squared b cubed? Are you going to expand it out? Well, you can. Nothing stops you from doing that. Or you're going to notice that the quick way is just to multiply that 20 with every exponent inside. It's almost like that distributive property, right? So we get 5 to the 20th, a to the 40, b to the 60th. Okay, so that you needed to know. So things you needed to know. And then I'm going to do a smaller version of that. Let's take 5, a to the second power, and 3 a to the, let me just write b to the third power. Let's say that was to the negative exponent of 4. So if you had previously, right, we talked about that if something like a to the 4, a to the negative third, right, or a number or anything to the negative third power, a quicker, shorter version would be to write it as a fraction over 1, right? So 1 over, and that takes care of our exponent, right? That's the shortcut. So based on that, you would say, okay, that's easy. So I'm going to put this whole thing over 1. And my exponent that was negative 4 is now 4. It's okay, nothing wrong with that, right? And then from here, we're going to go, see if I can move just this guy here. Okay. And then our next step would be to take care of the exponents, right? The expanded rule. So at the top, there's nothing to do. It's just 1 over. the bottom we have, well, remember there's a 1 here and there's a 1 here, so we get 5 to the 4th power, a to the 8th, 3 to the 4th power, b to the, and 3 times 4 is 12, right? We're not going to leave it as a complex fraction. We can, right, so remember, it's 1 over this. So that's the same thing as 1 divided by this whole fraction over here. So we can rewrite this as the multiplication problem. So we're going to 1 times the reciprocal, which is 3/4 b12, right, over 5/4 a8. Right, and then if you multiply this times 1, it's just this. And that would be a final answer. So what I'm trying to get at is that a shortcut, okay, or a different way of doing this would have been to do this. Let me just see if I can move these guys. I'll leave it on the screen. Let's see if I can move it. Yeah, I can. Right, so that's one way of doing it. The other way would have been, and if you did more of this, you would have asked, well, there's a shortcut, and the shortcut says I can just switch these two. The denominator becomes my numerator, my numerator becomes my denominator. Okay, so what if I switch, look, 5a squared, I'm throwing it down, 3b cubed, I'm making that my numerator. And then I can change the exponent to a positive. And let's say, and then after that, I would do the expanded rule, multiply everybody by 3, right? Including the exponents in the denominator. So I get 3 to the 4th, b3 times 4 is b12, and then 5 to the 1st is times 4 is 5 to the 4th, and 8 to the 2nd power times 4 is just 8 to the 8th. Look, we get exactly the same thing. So you can do this, yeah, what I initially had done. There's nothing wrong with that. It's actually, I think it's beautiful. Or you can take the shortcut. Okay. So there's a lot of rules. There's a lot of things to do over here. A lot of things. It's a matter of choice. And then I'm going to go to the right. Okay, so we're going to change, right? The numerator is going to become the denominator, and the denominator becomes the numerator. So let's rewrite that. We're going to get 3a cubed b negative 4. Don't change anything inside here. The only thing we're going to change is this guy here. Over 5a squared b negative 2 negative 3 c to the 0. And to the 4th power, we got rid of the exponent. Okay. Now, the other thing we're going to get rid of, so here's the thing. Now you can multiply the 4 times every exponent inside the parentheses, or you can still work on removing these negative exponents. It's up to you. So I'm going to the route that I'm going to change these negatives. So 3, nothing happens to it. 8 to the 3rd power is positive, nothing happens to it. Now, b to the negative 4th, think about what that is. That is 1 over b to the 4th, right? Didn't we talk about, so if this, this before, so if this was a negative exponent, and you want to change that to positive exponent, so we're just going to write it over 1 over b to the 4th, and that's the shortcut, right? So b to the 4th actually comes down here. C to the negative 2nd power, again, right? How do I make that positive? That's how I make it positive, right, over 1. So that comes downstairs to the denominator. So at the bottom, we have a 5, and the 5 actually stays in the denominator. Nothing happens to it. The a to the 2nd power, nothing happens to it. B to the negative 3rd. Now, if b to the negative 3rd is in the denominator, so that's going to end up in the numerator. All right, that's a shortcut. C to the 0 stays where it is, right? Actually, C to the 0, we talked about what a number to, or anything to the 0 power is, and that anything to that 0 power is 1, right? But if I multiply 1 times 5 times 8 to the 2nd power, b to the 4th power, c to the 2nd, doesn't that just become itself? So I don't even need that. Okay, and don't forget, now it's everything to the 4th power. Okay. So now, the other step you could do, you can simplify things, or you can multiply by 4. It's up to you. It's really up to you. You can simplify. So like there's a squared here. So let's look at the a. So I have a times a over a 8. That's what that says. What I mean by simplify, you can say this and this can simplify to 1, this and this can simplify to 1, and listen, literally that just means that there's one a here, right? Because everything else simplifies. So if you want to simplify, go ahead and then your simplified answer you multiply by the exponent before. You can do that. Actually, let's do it two ways. Let's do it one way you simplify and one way you don't. You simplify later. So let's simplify. So if I simplify, let me tell you what that looks like. That looks like this right now. A times a, b times b, all that in the numerator. 5, 2 a's, 4 b's, b times b, and 2 c's. All that raised to the fourth power. If I do that, this a and this a is gone. This a and this a is gone, right? Simplify to 1. So, and then b's, I have 1, 2, 3. We can simplify with 1, 2, 3. So I end up having leftover 3, a single a single 5 at the bottom, 1 b, and c to the times c, or c squared. That's being raised to the fourth power. From that, I can multiply the 4 times this little 1, the 4 times this little 1, the 4 times this little 1 here, and the little 1 in front of the exponent of b, and c squared. That would be the only one, which would be times 2. So my final answer would be 3 to the fourth power, a to the fourth power, 5 to the fourth power, b to the fourth power, and then c squared times 4, c to the 8th. We can change that one more step. 3 to the fourth power is 3, 9, 27, 81. 3 to the fourth power. The bottom is going to be 5 times 5, 25, 125, 625. And then b4, c8. Okay. Now, if you didn't simplify, okay, what happens if you didn't simplify right away? Well, if you didn't simplify right away, you're eventually going to have to simplify. So you will get, let's see what we get. So let's say you decide, I'm going to do right, the expandable. So I'll multiply that 4 times every exponent in here. So you get 3 to the third, 3 to the fourth, a to the 12, b to the 12 over, and then the 5, there's a little 1 here, 5 to the 4th, a to the 8th, b to the 16th, and don't forget the c to the 8th. Continuing that, now you can simplify. Well, 3 to the 4th we already know is 81. 5 to the 4th we know is 625. Now, I'm not going to rewrite a times 8 times 12 times. So I'm just, hopefully you get it by now. How many a? I have 12 a's being multiplied at the top and 8 a's being multiplied at the bottom. Right, so if I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over 1, 2, 3, 4, 5, 6, 7, 8. Again, if I simplify, right, where am I going to have leftover a's? On the top and the bottom? Obviously the top. How many will I have left over? Yeah, 4 of them. B12 and then B16, right? Again, if you line up all the 12s and line up all the 16s and you start crossing them out and simplifying, you're going to have 4 b's at the bottom left over. And c to the 8, we're not going to touch because there's nothing to simplify with. So either way you choose, right, you get the same answer. Hopefully that helped up a little bit.